everyone, my name is Ronan. I work here at the Colony Public Library. I'm kind of the resident science enthusiast. I'm very excited because we're going to do some science experiments today. And you can follow along and do these at home as well, so this will be really fun. So today we're going to be learning about chemistry. Do you know what chemistry is? When you think of chemistry, you might think of scientists mixing things together, maybe wearing a lab coat or goggles or something. Maybe they make an explosion. So that can happen in chemistry, but that's not the study of chemistry. The definition, the study of chemistry, is the study of matter. Do you know what matter is? It might sound familiar. So matter, the definition is anything that has mass or weight and takes up space. So another easier way of remembering that is anything that is stuff. That's easy to think of, right? Because there's a lot of stuff around us. So is this table matter? Yeah, it's stuff. Is the floor matter? Yep, also stuff. Am I matter? Are you matter? Yep, we are made of stuff. So there's a lot of stuff around us that's made of matter. So let me ask you a trick question. Do you think the air is made of matter? So let's do a quick experiment. So an experiment, we first need to make a hypothesis. You know what that word hypothesis is? Do you want to say that along with me? Hypothesis. So what does that mean? It's kind of a fancy word. That basically means a scientific guess or educated guess. So we're going to use our brains and make a guess on what's going to happen. So what do you think? Do you think the air is matter or not? I'll let you think about that for a second. And let's do our experiment. We're going to test out our hypothesis. So to do this, we need to take a deep breath of air. So let's do that. Count of 3. 3, 2, 1. Don't let that air out. And take another deep breath. And take another. Can you do it? No. Gotta let that air out. So why couldn't we just keep breathing air into our lungs? What was stopping it? The air was filling up space in our lungs, right? So our lungs are kind of like a balloon. We're breathing in air and it's taking up space, getting bigger and bigger, and there's a certain point where our lungs can't take anymore and it has to let that air out. So does that mean the air is matter? Yes, because it was taking up space. So even if we can't really see air or interact with air, it still has an effect on us, it still takes up space, it still has a small amount of mass, so it's still matter. And you guys might have heard of states of matter before, right? There are 3 states of matter. What are they? There's a solid, there's a liquid, and a gas, right? So 3 states of matter. And we're going to be seeing those states of matter in our experiments today. But before we get to our experiments, we have to talk about one more thing. There's 2 ways that we can change matter. We're going to talk about one today. There's physical change and chemical change. So physical change, that's what we're going to be learning about today, is when the molecules of matter get moved around. They might change states of matter. They might float or sink or change temperature, things like that. But the point is that that object that we started off with, the material we started off with, stays the same material. It doesn't change it to something else, and we can easily change it back to whatever state it was before. So let's think of a quick example. If I have an ice cube in my hand, what state of matter is that? It's a solid, right? And what is that ice cube made of? It's made of water. So it's solid water in my hand. And what will eventually happen if I leave it in my hand? It will start to melt, right? And it turns into what state of matter after that? A liquid. So now we have liquid water. Can I change it back to solid water? Yeah, I can just put it in the freezer, right? And it stayed water the whole time, even though it was a solid in one instance and then it turned into a liquid. It's still water, it's still H2O. So that's a good example of physical change because we move state of matter, we change temperature, we move those molecules around, but it's still H2O, it's still water. The material stayed the same and we can easily move it from solid to a liquid. So we're going to talk about physical change. We're going to do an experiment on physical change. And we'll talk about chemical change in another video. So are you ready to get started on our experiment? I am. It's going to be really fun and exciting, and I hope you can do it at home because it'll be fun to see it up close in person. All right, so these are the ingredients you'll need at home. You'll need a soda of some kind, so probably a clear soda would be best, but if you don't have that, that's totally okay. You'll need a cup to put the soda in, and you'll also need some lentils. These are kind of like a bean a little bit. So if you don't have lentils, you can probably find something else, like maybe dry beans or things. We'll might ask you at the end if you can think of anything else to add to your experiment. But we're gonna do lentils in our experiment. All right, so first let's open up our can of soda. Ooh, that's always fun to do, right? That kind of pop. We'll talk about what that pop means. Let's pour some in. And let's make an observation on the soda before we do anything else. So what's an observation, first of all? An observation is when we use our senses to kind of get a sense of the world around us. So let's use our eyes and our ears and just talk about this soda for a second. So what do we see? So I see that it's a liquid, right? That's one of our states of matter. But what are these other things that's in the liquid? Those are bubbles, right? What does it mean when there's bubbles? It means that there's a gas. There's a gas in our liquid. That's what makes the soda so exciting, especially when we opened it, and what makes it taste good. Do you know what that gas is specifically? So let's figure out. When we breathe in, what do we breathe in? We breathe in oxygen. That's what keeps our body alive. What do we breathe out? We breathe out carbon dioxide. So carbon dioxide is the same gas that's in our soda. So our soda is a liquid and it's a gas. So this is called a mixture, when there are two or more materials mixed together to make one thing. And this is kind of a special mixture because not only are there a bunch of stuff in the liquid, but they're also evenly mixed together. Our liquid is made of sugar and water to make it taste good, make it yummy, and it's also got that carbon dioxide. And it's all evenly mixed together to make one liquid, one substance. So it's a solution. So our mixture is a special mixture called a solution. All right, we've observed our soda. It's a liquid and a gas. So let's add some of our solid, our lentils. I'm just gonna add a little bit. So before we do this, let's make another hypothesis. Remember that word hypothesis? We're gonna make a guess on what will happen when we add the lentils to our soda. So you can write this down, you can tell your parents or your siblings, or you can just keep it in your head. So let's make a hypothesis really quick. Do you have one? Okay, let's drop these lentils in, and then we'll spend a few seconds observing them. Ooh, do you see that? All right, I think that's enough time observing this. So what I saw was we dropped some lentils in, most of them sank to the bottom, some floated to the top right off the bat, and then after a while, some popped up to the top again, right? That's weird. So why did they sink and then they floated, and some even started off floating? So what we're doing is we're observing a physical property called density. So density is, in this case, looking at an object's ability to sink or float. So the definition of density is an object's mass, or its weight, compared to the volume, or the space that it takes up. So to make something sink, the density has to be greater than the liquid that it's in. To make something float, the density has to be less than the liquid that it's in. So starting off, the density of the lentils was greater than the density of the soda, so it sank to the bottom. But then, why did it shoot up to the top? What was happening? Did you also observe that some bubbles collected around the lentils, and just as soon as enough bubbles collected, it boop, shot to the top? So the bubbles affected the density of the lentils. It made the density of the lentils less than that of the liquid, so it could shoot and float to the top. Have you seen that happen in real life? Have you ever gone swimming with like an inner tube or water wings or something? So you yourself, you probably sink to the bottom of a pool, but then you wear some water wings and inner tube and you're able to float on top, right? So the water wings are acting like the bubbles here, where they make the object float to the top. It's changing the density of the object. And I think that's really cool. We can sit and observe this for a little bit longer and see those lentils float to the top, and then the bubbles pop, and then they sink to the bottom. We can just keep watching this, and it's kind of fun to watch. All right, so this was a really good example of physical change, because we started off with the soda, which is made of liquid. It's a water and sugar mixture, and we also started off with those lentils. And so we ended up with the same things, right? We still have the soda, which is the liquid, the water, the sugar, and the carbon dioxide, and we still have the lentils. The lentils didn't change into anything else. The soda didn't change into anything else. And we observed some physical properties, and we saw some physical changes of the lentils moving up and down, of the soda, the bubbles popping, things like that. But our objects the materials stayed the same as to what they were when we started off with. But we also observed some physical properties, right? We saw the density. We also saw things float and sink. We saw the state of matter that these objects were in. So we observed physical properties. What other physical properties are there that we can observe in an object? We can observe temperature. If we had a thermometer, we could check the temperature of the soda. We can observe color and texture and shape, things like that. Those are some other physical properties we can observe with our eyeballs. So now it's your turn. You can go home, look around your house. You can observe physical properties of other objects in your house. You can find other examples of physical changes in your house. I can think of a lot just off the top of my head, so I hope you can think of some too. This is a good time for you to get a notebook or a piece of paper and just write some observations down, because that's what makes it fun and exciting, and more like science is writing your notes down so you can look back to it later and remember what you learned. So I hope you have found some cool stuff at home. I hope you had fun with our experiment today. Our next video, we're going to learn about chemical change, and I'm really excited about that one, so I hope you can come back and watch the video then. All right, see you later. Bye.